Section 2.5 is all dealing with prime factorization. Remember in the last section we were learning about prime numbers. The common, most used prime numbers are going to be 2, 3, 5, 7, 11, 13, etc. Prime numbers, of course, go on forever, but the ones we're going to be most concentrating in for this lesson are going to be these. So when we prime factorization, we can take any number and break it down into prime factors. Hence the name prime factorization. So let's say that we had 30 and we were going to prime factor that. As you can see in the book, basically they're doing branches. We call these trees in the mathematical world here. So we're making a tree here. So these branches of the tree are pointing up to the number above it. So we can pick two numbers and multiply together to get 30. We could do 3 and 10. Well, we notice that 3 is on our list, and personally I like to kind of circle that so I know that that's part of the answer. If the other number is not on the list, it's going to get another branch. 10 is composite, it's not a prime, therefore it gets a branch. So what times what is 10? Well, 2 and 5. They're both prime numbers, so they're going to get circled. Now I'm down to all prime numbers, and so my prime factorization is 2 times 3 times 5. Now I could have done this a different way. If let's say that I wanted to do 30 and I wanted to go 6 times 5. Perfectly acceptable, not a problem at all. 5 is on my list of prime factors, so it's going to get a circle. And then this number is going to get a branch because it's composite, so it gets another branch. Remember, these two numbers have to be multiplied together to get the number above. So we have 2 and 3. Well, 2 times 3 is 6. They're both prime. They get circled. And again, the numbers are the same. The answer is the answer. How we get there is completely up to you. So let's pick another number. Let's do, we're going to do 100. Okay, 100 is composite because it's even, therefore it has to be factored. Again, we can do it a couple of different ways, and we'll do 2 examples here. So what times what's 100 we want to start with? Let's do 2 and 50. Well, 2's on our list, so it's going to get a circle for part of the answer. This is a composite number, so it's going to get a branch. So what times what is 10? We can pick a couple ways, but let's go 5 times 10, or what times what is 50. 5 is on our list, it gets part of the answer. 10 is not, gets another branch. 2 times 5. Okay, so our answer is going to be 2 times 2 times 5 times 5. Then we would write it in exponential form, 2 squared times 5 squared. So this is not wrong, but this is the more correct way to do it. So let's say we wanted to do 4 times 25. Either one of these are prime, or they get branches on each. 4 is 2 times 2. They're both prime. They get circled as they're part of the answer. 25 is 5 times 5. Same answer. 2, 2, 5, 5. Again, 2 squared times 5 squared because the answer is the answer. So let's take one more number. How about 160? 160 is problem number 30 out of the textbook. Just grabbed a number there at random. So we can do any branch we want to do. Well, it's the power of 10 because it ends in a 0, so let's do 10 times 16. Neither one of these are prime because they're both even numbers, therefore they're composites, so they get branches again. 10 is 2 times 5. They're both prime. They're going to get circled. 4 times 4, 16. Neither one of those are prime, therefore they both get another branch. 2 times 2 and 2 times 2. All of those are part of the answer. They get circles. So I have 1, 2, 3, 4, 5 2's. 2 to the 5th times 5. We could also do it a different way. Say we did 40 times to a branch, 40 times 4. Okay, 40 is composite, therefore it gets a branch. How about 5 and 8? Different way to do that. 5 and 8, 5's prime, 8's not. 2 times 4, 2 is, 4 is not. Gets 2 more 2's. We can't forget here because we haven't done that yet, so it's going to get branches 2 and 2. Now I have circles at the end of all of my branches. I've still got 1, 2, 3, 4, 5 2's and 1 5. So the answer is the answer. Doesn't matter how you go about doing it, you're going to get the same answer. Doesn't matter which way you start, the answer is the answer. Good luck with the problems.